Welcome to Vidhai. I'm Rahul. I'm a volunteer in Vidhai and this is my very first video on Vidhai. So let's get started. So Exams Vidhai is a non-profit initiative by the students of IIITDM to give free coaching and resources to students to prepare for exams like NTSE and NMMS. So today we are going to see the number system. So the contents of the chapter is the number representation. So we will see what is the representation and things, and natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So what are numbers? So numbers are basically the symbol used to represent the answer to the question how many. So you can come across this question a lot of times in your life. How many liters of milk should I buy today? How many kilograms of sugar you have to buy? So how many kilograms of mango? So like that, you will always end up with the question of how many. So numbers are just symbols purely defined and used by humans to represent the answer to the question how many. So the answer just lies in your mind. That can be precisely defined by the humans. That can be only felt by humans. So but numbers are symbols that are used to represent them in papers, databases and things. So communicate with others. So we always see the whole as numbers related to some basic quantity. If you go and ask how many watts is this bulb, they will say 100 watts. So 1 watt is some basic quantity and you are comparing to something as 100 watts, so 100 times as this. Have you ever wondered the question, have you ever wondered why we always count up to 10? What we do is we will count up from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Have you ever wondered why we do that? The answer completely lies in your hand. Go back to your childhood. Your first standard teacher might have thought to count using your fingers. What will you do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will count like that. So in early days, humans too used to do count numbers using their fingers. So they eventually ended with the number system of based in not only the Arabic numeral system that we follow. Take the Tamil numeral system, they have 0 to 9. Take Greek system, they have 0 to 9. Almost every other system in the world has 0 to 9, 0 to 9, and Chinese system has 0 to 60. 60 is nothing but just a 6 times of 10, so that's an integral multiple of 10. So it is almost used by everyone. This Arabic numeral system is adopted by everyone because of the British went to everywhere and captured. So they are just easy to use. So we just stick to it. But number system is just a representation of what already exists, and things won't change irrespective of whatever system we choose. Just remember that thing. So in computers they use binary systems. So in binary systems you will have zeros and ones. So what will you do? You represent 0 as 0 and 1 as 1. After that you are exhausted with numbers. So what will you do? You add a digit to the left. To represent 2 you are doing 1 0. So to represent 3 you are just increasing 1 1. So again you are exhausted with numbers. So to represent 4 what will you do? You will add a digit to the left side. So 1 0 0. So for computers some reason they are using the binary digit. You will learn that in absolutely you will learn that. There's also a system called hexadecimal system which is commonly used to write programs and things. We keep on adding digits to the left side to represent the huge numbers when the symbols run out. So can we say a maximum number beyond which no number exists? Just think of it. Irrespective of whatever number you say, there's always exists a number which is greater than in our consciousness. We can imagine such a number greater than some number, one more. So there's no absolute maximum when it comes to numbers. There are always something greater than a greater thing you can imagine. So we use infinity to denote something that is endless and maximum than everything. We don't know what's the value of infinity absolutely, but remember infinity is simple to denote something too big. That's bigger than everything. So now we have an idea of what is numbers. So let's get to some definitions. So natural numbers. So how do we used to count? We use our fingers. we just imagine you are in a garden. So in a garden, so you are counting the number of apples. So what will you see? One apple, two apple, three apple. So naturally, what will you count is one, two, three, four, five, and so on. So that is what natural numbers is. So in nature, this is how it exists. There's one, two, three, four. That's how we count. So by convention, we denote it by the letter n, and it consists of the numbers 1, 2, 3, 1 to like infinity. So whole numbers. So whole numbers are nothing but natural numbers plus nothing. So we wanted a way to represent nothing. So you are in an app. Zero is a simple used to denote nothing. So whole numbers is simply 0 plus natural numbers. So by convention, we denote whole numbers by letter W. So you might have come across the term negative numbers. So negative numbers doesn't exist in real life, but they created completely for our convenience. So you cannot go and see minus 10 apples or minus 10 liters of milk. So they're just created for our convenience to represent the opposite of what is represented using natural numbers and quantities that has to be subtracted from other quantity. For example, you are checking your bank balance. So that will show some positive number, some 10,000 or something. Suppose if you fail to maintain the minimum balance, they will put some fine. So you have to pay them some 20 or 30 rupees, and at that time your balance will show minus 20. So it's just the opposite. So the positive number is the bank has to pay some amount, that amount is represented as positive, and the negative number is we have to pay them. So they will just subtract the thing from what we have. So that is the necessity of negative numbers, and we use that. So mention it as a negative numbers. So integers are nothing but collection of negative numbers plus whole numbers. So minus 5, minus 4, so minus from minus infinity to infinity. So they're represented by the letter Z. So let us quickly jump into the formal definition of rational numbers. We have so far seen natural numbers, whole numbers, and integers. So let me define what is a rational number. A rational number, according to formal definition, a rational number in mathematics can be defined as any number which can be represented in the form of p by q, where q should not be equal to 0, where p and q are integers. They can be any integers and q should not be equal to 0. So whenever there's a rational number which can be divided, when the numerator is divided by the denominator, the result will be in decimal form, as you know, which can be either a terminating decimal or a repeating decimal. Let me take 1 by 2. Well, will you divide 1 by 2? So you can't divide 1 which is smaller than 2, so you have a decimal point. And 10, so 5 2s are 10, so 10 it's 0, so 0 0.5. But how will you represent 1 by 3? So try to divide the same way. So 1 is smaller than 3, so we will add a point, decimal point. So 10 is the, so 3 3s are 9, 9. You again come with the repetition of 10, so 3, again you will have 10. So this will never end. So 1 by 3, so 1 by 3 is 0.333333 repeated. So this is, so we have enough things to count. We have tools to count things like natural numbers, whole numbers, and even integers. So if you see, the world is not based of a single unit, separate units. They are often based of smaller building blocks, just like a building is made up of bricks. A brick is further made up of sand. A sand is made up of atoms. Atoms is further made up of electrons, protons, and neutrons. And electrons is further made up of quarks. And we have not identified what quarks is made up of. They may be made up of something else. It's often hard to express everything in terms of the basic unit. if you want to express a building in terms of an atom, so see how huge it will be and how inconvenient it will be. So what we will do is we assume some other unit as some big unit as basic unit and represent smaller things on that unit. For example, let's say a building is made up of 1000 bricks. We want to represent everything in terms of building. So what will do a single brick? 1 by 1000. So this is what a fraction means. So it made up of some 1000 parts, and the single part of that thing is the fraction. So the fraction represents. So it's completely for our convenience, and in nature there's no single basic thing exists. So always if you find anything that is made up of something else, so we always, no matter what system we choose, we always need fractions to represent some units. So we assume that the larger unit is divided into equal parts of denoted by the denominator, and numerator represents this many parts. So that's what a fraction basically represents. So decimal number, since we use a 10-digit system, we assume that everything is filled from 10 smaller units. So what will we do is we count 0 to 9 and we will add a number 1 after that the 0. What does it means? This place is made up of 10 such right units in the right side. So hundreds is made up of 10 tens. Tens is made up of 10 ones. So sometimes this will not be sufficient, so we need decimal numbers. So after the point some number will exist that is made up of, actually that 10 times that thing, 10 times of 0.1 makes 1. So we often add that we continue the decimal numbers by adding a point to it. So in some decimal representation systems, you cannot represent every number as a finite terminating number. So we need fractions to represent, like 1 by 3 equal to 0.33333 something. But if you take another system, number system, in tens number, in a number system which consists of base 10, you can't represent 1 by 3. But if you consider a number system that is made up of base 6, you can easily represent. Let's see that in the upcoming slides. So assume a pizza is made up of 10 pieces, and every piece in turn can be divided into 10 pieces. So you are given a task. There are 3 members, there are 1 pizza. So that pizza can be divided into 10 pieces. If some piece exists separately, you can divide it further as 10 pieces. Nothing other than that. So what will you do is you will give 3 pieces to each person. So there are 9 pieces that went off, and there is 1 piece remaining. So you have to divide that piece. So if you divide that thing, you again give 3 pieces to each, and one piece is remaining. You have to divide and divide and divide. That will infinitely go on. But assume the same pizza is made of 6 pieces. You just see this is made up of 6 pieces. You can easily give each of them 10 pieces. So actually we have said in the starting that the system we choose should not bother our results. So that's why even the repetitive decimals are added to rational numbers. So if you choose a number system which has up to base 6, you can easily represent 1 by 3. So that's not a big deal. So you will see that as 0.2, 1 by 3. So this is a finite number. So that's why we even include infinite repetitions of decimals as rational numbers. So we said that the world is made of smaller units, and they are made of much smaller units, and the smaller unit is made up of another smaller units. So we will never find the basic units. We have never found that, and we will never find that. So any number you think, we can further divide that. You can further divide that. You can further divide, keep on dividing that. So just like humanity, we cannot find a number which is extremely small, and other than there's no smaller number exists. I mean except 0. So if 0 is nothing, so let's exclude that thing. So if you take 0.0001, the smaller number exists, 0.00001. So there's always a number smaller than something. So that is what we define as infinitesimal. So infinitesimal is something, it's highly very small. So it's almost zero but not zero. We often denote that as tends to zero. You will learn that in calculus and things. So see, infinitesimal is tends to zero but it's never zero. As you see, this block is divided into pieces and after that it keep on repeating. So you can never find something absolute minimum, just like absolute maximum. So we have seen rational numbers. Now let's come to irrational numbers. So according to formal definition, numbers which can't be expressed as a fraction are called irrational numbers. So see, if some number cannot be represented in the PVQ form, you call that as irrational number. So to be a bit informal, let's say numbers which cannot be visualized as a building block of some unit in any number system. Just don't take 10 places like that. In any number system, you cannot imagine the thing as a building block or something like we visualize pizza buildings like that. So that is irrational. So do such numbers even exist? This question will definitely arise in you, that cannot be visualized. So the answer is yes and no. So irrational numbers are numbers that represent perfect situation of imperfect conditions. So there's some condition that's always imperfect. You want to represent the perfect condition of that imperfect situation. What will you do? You define some number. So that's an irrational number. For example, take the square root of 2. So 2 the number can be the number, there's no exactly a single number. Squaring with itself and multiplying with itself gives 2. So that the definition is that there's some number that when multiplied with itself should give 2. The square root of 2 is 1.414 and a lot of digits will be there and you will never ever find the end of the digits. So we define a number called root 2 which when squared perfectly gives the value 2. So how will you represent it? Like this, root 2. So you can't give an exact value for that. It has infinite decimal points in it. So further, let's say why pi is considered irrational. We are coming to the important question, why pi is considered irrational. So as you know, pi is represented by this symbol. So it is often used to represent the formulas of circles and everything. So by definition, pi is the ratio between circumference of a circle and radius of the circle. So let us just see what is a circle. So circle is a path joining all the points at fixed distance from the center. If you take a compass, what will do, you fix a center and you will measure some radius and you will connect the points and if you will connect a circle. So circle is a path joining all the points at a fixed distance from the center and radius is the distance between the center and any point on the circle. So circumference is just the length of the path. So in order to really measure the circumference, you have to connect infinite number of points in the path, because between any single point and a given distance there are infinite points. So in order to truly represent the circle, you have to connect every point, which is literally impossible. So since infinite is not perfectly defined, you cannot perfectly define a circle or perfectly draw a circle. So what will you do? You will often end up with creating approximate version of circle. Let us just see in this video. So see, here they are having 3 points and 4 points, 5, 6. As the number of points increases, this looks like a circle. So that's how we measure, we see circles. So we cannot define a perfect circle. So what will we do is, pi is an perfect representation of an imperfect condition. So circle is an imperfect thing and the perfect representation is pi. So if you ever wondered what is the real value of pi, just go and check out in this link. They will have the website will have the first 100,000 digits of pi and it keeps on going. You will keep on adding the numbers, you will never reach the end. That's why pi is rational. Quick summary of what you have seen so far. So numbers are symbols used to represent the answer to how many. Natural numbers are numbers we see in nature, 1, 2, 3. Whole numbers are 0 plus natural numbers, and negative and integers are negative numbers plus natural numbers. Whole and rational numbers are those which can be expressed as a fraction of two integers whose denominator is not 0. Irrational numbers are just opposite of it. So rational numbers can be initialized, irrational cannot. Any finite decimal number or a repeated decimal number is rational. Irrational numbers are numbers that represent perfect situation of imperfect addition, just like pi and square root of 2. So that's for it today. So in the next video we will see properties and operation of different numbers and the number systems. So thank you for attending. Please check the description for extra questions and lecture notes of each chapters. Please like, share and subscribe. Thank you.